Hello guys, I'm Aluko Shao Enoch and welcome to my math tutorial class on vectors. And in today's session, we shall be taking a look at the GCSE exam style question on position vectors, vectors geometry and relative velocity. So guys, let's get started with the first question. O is the origin and P is the point 1, comma 5 and PQ is 3, 5. Okay, so find OQ. Okay guys, let me just go ahead and demarcate my board in order to manage this space very well. So I think I should go ahead and also demarcate this place. I can start solving my problem here guys. Okay, so let's get started. Now don't forget this is some column vector, so you can represent your vector like this. It's a column vector. So I'm to find OQ guys. Don't forget generally, let me go back to this. If you have this is PQ, okay, PQ, and you can also be sure that you indicate your the direction. Vector is this vector, not scalar. Okay, so it has both magnitude and direction. Now this is the first letter, so you pad it because what I have here, if I want to write this one and since origin, that is position vector. For example, OP, okay, that's a position vector. So for position vector P means OP, position vector Q means OQ, something like that. Now if I want to rewrite this one, so I can, this is P, the first letter that starts P, then you pad it with O, PO, then plus OQ. Now if you look at what I have here, let me just quickly explain something because I'll use this rule very well, very much better. Now the letter, this is the first letter P and this is the last letter based on what you have here, so you pad it with a constant like maybe letter like that. Oh, for example, if I want to write something like let's say TQ, okay, and I want to break it down as a component of its position vector, so this is T, so I can write it as TO, then plus OQ, etc, like that. So I'm going to use this rule um, much more, yeah, as we go ahead in this section. Okay, so yeah, let's just continue now. Okay, so now this is what I have here. Now however, I don't need this. I just call your attention to this. So what I need to find is OQ. So let's go ahead with OQ. So OQ. Okay. So I'm going to use that rule, guys. So I want Q last. So I can have something like OP, something like that. OP. Okay. Then plus. So I can cancel this last one, cancel this first one here. Okay. So then I want to cancel out P. So you can have P. Then the last letter is Q. So that is clear guys. I've tried for you guys. Okay, so this is cool, right? Cool. So you should be able to write your stuff like that. So you can see that this is the last, cancel this, so you are left with OQ. So what do I have there? OP. Do I have OP? Yeah. Now this is position vector, this position origin, this OP. Okay, that's this OP, this one here, this given one here. So I don't know why I'm taking my time here because this is the first question. So let me just explain everything. So position vector P, that's OP. Position vector Q, that will be OQ. Position vector E means OE or something like that. So that's it. So OP, I'm going to write it as a column vector, guys. So my OP is what? This is O is the origin. So P is the point. So that is OP is 1, 5. Oh, that is cool. 1, 5. Then plus PQ. So I have PQ already. That's 3, 5. Okay. So what do I have there? So my final answer is what? Just sum this I component, this j component. So sum the I component. That is 4 and 8. Guys, hope that is clear. 5 plus, sorry, why did I put 8? Is that not 5? Is that not 5 plus 5? Sorry about that. So 5 plus 5 is 10, guys. 5 plus 5 is 10. So that is 410. So let me just go ahead and take my eraser. So this is 410. So 410. Okay, so that's pretty cool. That's the solution to 2A. So let's go ahead with the next question. So this b, let's solve b here. So I don't need to waste much time explaining how to resolve your vectors again, because you understand everything now. So like such that this one cancel out this, something like that. So you have your OK. Okay, so now this one, now OE is the origin, so meaning that the position vector of E, so you can write it as OE, and it's given already. So OE is given, and is what? That is, I'm going to write it as a column vector, so that is minus 3 4. Okay, and you also have EF. I don't need to rewrite this in order not to, such as to manage my board very well. So this is minus 2 7, so we have to find position vector F. So position vector F means that that is OF. Let me just go ahead and demarcate this so that I can solve the last one here. I think that will be pretty cool, right? So I'm looking for what? Position vector F. So position vector F means that OF, okay, from the origin. So now it's what I'm looking for. So let's go ahead and do the padding. So I have O to start. I'm going to pad with E based on what I have here. Okay, because you have EF already. So I can write this one as OE. Okay, OE. Then plus. So I want E to cancel out E. So that will be EF. Guys, hope this is pretty cool, guys. I need to take my time to explain this, but as we go on in the section, I need not to waste much time. I'll just go ahead and express it. Okay, so yeah, so what is my OE? And don't forget also, don't worry, let me just explain that. So do we have OE? What am I looking for? OF. So do I have OE? Yes, I do. So because this is OE and it's a minus 3 4, minus 3 4, then EF. Do I have EF? Yes, EF. That is minus 2. So plus, okay, minus 2 7. I need not to explain so many concepts now until when there is a need to accordingly. So yeah, so this minus just the I component first, so that is minus 3 minus 2, that is minus 5, and the J component, so 4 plus 3, that is 11. Guys, so hope that is pretty cool, guys. Pretty cool, right? Pretty cool. So that is what that solution to be. So let's go ahead with C. Let me solve C here. So this one's O is origin and M is point, so this is OM now. So OM of everything is correct. So OM, now say that position vector of yeah, so position vector M, or better still OM. Okay, so that's it. So this equals to let me write it as a column vector, that is 4 minus 2. Okay, why am I, yeah, cool, pretty cool, no problem. Find the position vector of N, so I'm looking for ON. Okay, ON, I don't know what this is. Okay, so we can put question mark. So let's go ahead and resolve now. So ON equals what? So I'm going to pad with N. So this is O, O start here, so I'm padding with M, OM plus MN. Okay, so that you have ON. Okay, so if you don't mind, just go ahead and put your direction arrow. Okay, so what do we have there? Do I have OM? Yes, OM is given, that is 4 2. I have OM, that is 4 2. Yeah. Do I have MN? So you come here, this is NM. Okay, so now if you want to write there, so that's opposite direction. So NM is the same thing now, so better still MN. Let me just write it here. MN will be equals to minus NM, and vice versa. Okay, don't forget, guys. So if you want to put your arrow, no problem. So now mean that I need negative of this, so I can do minus of this. If you don't mind, yeah, minus, okay, NM, because I have N. Okay. But I don't know why I put this like this. Yeah, okay. Let me just do something here such that so that they don't combine numbers with letters. Okay, can you give me my razor? So let me just re-express this one. Okay, so let me leave it as letter to letter first. So this one is OM. Guys, so this is pretty cool. Everything is clear, right? Okay, so we can write it as a column vector now. So that is 4 2. Okay guys, I actually want to use this one the way it is, so just put negative. So minus, so you are going to have what? So I want to use addition here, plus, then okay, minus 3, then minus 5 will be 5. Guys, you guys are add math student, additional mathematics students, so this is pretty cool. Hope you understand what I'm doing. So 4 minus 3, that is 1, and 2, and this 7, 1 7. Guys, look, I'm cool. Yep. This is 4 minus 2, and I put 4 2. This is 4 minus 2. So 4 minus 2. Sorry about that, guys. 4 minus 2. Okay, because OM is 4 minus 2 here. So that is 1. The minus 2 plus 5 is 3. Okay, sorry about that. K 3. So that's the answer. 1 3. So guys, this is the end of the first question. Let's go ahead to the next question, guys. Okay guys, here is the next question. At 12:00 hours, a ship leave a port quay with position vector 10I plus 38j kilometer relative to an origin O. The ship travels with velocity 6I minus 8j kilometer per hour. Find the speed of the ship. B. Find the position vector of the ship at 3 p.m. C. Find the position vector of the ship t hours after leaving Q. D. Find the time when the ship is at the point with position vector 61I minus 30j kilometer. Okay guys, let's get started with the question. Okay, so the first thing I'm going to do here is we'll go ahead with the speed. Don't forget that speed is a scalar quantity, and you're going to get that from what? From your velocity. So that is the magnitude of this. Okay, and it's not directional, so no I and j. So to find the magnitude, just go ahead and find the magnitude of this, and that will give you the speed. Okay, so speed of the ship equals to square root of the x component, so that is c square, plus the y component, that is minus a square, but you can just use an 8 square, because if you square that is going to give you positive. Okay, so that's square root of what? This is solution to a. Okay, so that's square root of 36 plus 64. 36 plus 64. Okay, so and that is square root of 100, if I'm right. Yeah, so that's square root of 100. Square root of 100. So what's square root of 100? That is 10. So the speed of the ship is 10 kilometer per hour. 10 km per hour. Okay, so that's pretty cool, guys. Next question, B. Let me just go ahead and demarcate this so that to manage my board, so as to be able to manage my board effectively, guys. Okay, so for B, the B part here now says that we should find the position vector of the ship at 3 p.m. Okay, don't forget that the rule, when you have an object with an initial position A, move with a constant speed V, then the position vector is given as this. So the position vector is given as A. Sorry about that. A. So this A is the initial position. Moving with a constant speed V. So then at time t, so the position vector is given as r equals to a plus tv. Okay, so yeah, what's my a now? This is this here. So you have 10I plus 38j. Okay, and your v at constant speed, this one here. So that what we work with now. Okay, so let's go ahead and do that. I'm going to express it in as a column vector. So let's express this position vector as a column vector. That is 10I minus 8j, then plus, so at time what? 3 hours. Okay, so now from 12 to 3, that's how many hours? Now 12 to 1, that is 1, then 12 to 3, so that's 3 hours. 12, 1 to 3, so that's 3 hours. So 3 hours difference between 3 and 12, that's 3 hours difference, guys. So the time is 3, and the velocity is now also expressed that as a position vector. That is I minus 8j, minus 8j. Okay, so that's that. So let's complete this one now. So this equals to 10i. Okay, so I'll use this is color product, use it to multiply through. So 3 times 6 is 18. 18i. I don't know my handwriting. What is going on? 18i. Okay, so I can put this one in big bracket. This is minus 8j. Then minus 8 times 3 is 24, so that's minus 24j. Okay, so you can do the addition. So the position vector is guys, position vector, I don't actually need the direction, don't forget. Yeah, but it's cool just to show you how at this. So I'm going to write the final answer without the direction. So yeah, 10 plus 18, that is 28. Okay, and minus, what am I doing? Yeah, this is 10i and 838, and for some reason I wrote, what is going on here? 10i plus 38j. Yeah, this is plus 38, and this is sorry about that, this is 10i plus 38j. What, how come I use 8 here too? Yeah, this is correct. Okay, this is 38, sorry about that. Plus 38, can I change it here? This is 38. Okay, but I can't change this one, so I need to use my eraser. For some reason, can't I see this alcohol? You can't see. Sorry about that. Okay, because this is 30. This is 38, guys. This is 38. 1038, and it's plus. I don't know what am I doing. Okay, so yeah, 38. Sorry about that. 38. So this is 38 J. Okay, so yeah, here's my calculator. 38 minus 24. 38 minus 24, that is 40. 14. Okay, so that's pretty cool, right? Yeah, okay, so that's solution to question B. Let's go to C. Okay, and this one says that find the position vector of the ship T as after leaving Q. So this is it here now. So this is how to find this. So I'm going to write R equals A, that is the initial position, that is 10i plus 10i. I'm going to write, express it as a column vector. So 10i 38j. Okay, open bracket and close, and I need not to put the I, but it's cool, no trouble. Then C into V. I don't need to put the I to be candid. Can I just go ahead and write it the normal way, so that I don't need to waste much time? I don't want to rewrite it again, so just remove the direction. Okay, so yeah, let's just remove direction, is uncalled for, since I'm not going to work on it yet, and just leave it like that, just to express it. So T into what is V? 6 and minus it. 6 minus it. Pretty cool, right? Finally, D. Wait, afterwards, yeah, T. So not given. So I need to retain the variable T. So D now says that find the time when the ship is at the point with position vector this. Now, meaning that with position vector, find the time, find this T, giving this R to be 61i minus 30j. So yeah, since I want to find T, so let me just write this one first, but let me just write something here. When R, that's from C, so when R is given, and as a position, as a column vector, better still, 61i minus 30j. So sorry about that, guys. I don't know, I just need to write it like this. So this time around I'm going to include the direction in order to just equate. So yeah, I'm going to write this one on the left hand side first, because I want the variable to be on the left hand side. So I have 10i 38j okay, plus, and because I need to manage my board very well, so I just want to use this one to open up. So t times this one, this is I, so no problem about that anyway. So just write t into 6i minus 8j, okay, then equals to, and that's the 61 I minus 30 j, 61 I. Oh my, 61 I. Sorry about that. Okay, so I can put it in brackets. Okay, so now you can go ahead and open up this one, and better still, we can form equation now. So the I component of the equation is something like can I just write it the way it is, or you can multiply this one first. So I have something like, yeah, no problem, 10 plus 6t. So that's the I component, so equals to this one here, 61. So this is equation 1. Okay, then the j component, I have 38 minus 38 minus, this is minus 8, minus 8 times 6 minus 8t, okay, equals to the j component minus 30. So that's equation 2. Okay, so I'm going to solve the system of equations simultaneously, and in order to solve for t, so I'll add equation 1 and 2. So add the two equations together. So you have to sum the equation. Now what do we have here? So 38 plus 38 plus 10, that is 48. Okay, minus 80 plus 60, that is minus 50. 61 minus 30, that is 31. So then I have minus 50. 31 minus 48, that is minus 17. Minus 17. Then I divide both sides by minus 2, so t will be 8.5. So when t is 8.5 now, that is 8 hours 30 minutes, something like that, 8 hours 30 minutes. Let's just continue. We have from 12 hours, the shift start at 12 hours, so you have 8 hours and 30 minutes more, so that gives you what? So 8 plus 12 is 20. 12, then 8 hours later, that's 20. So that will be 20 30, guys. 20 30. Okay, 20 30, that's the solution to the question, guys. So here is the next question, and displacement equals to 21 I plus 54j meter, and time taken is 6 seconds. Find the velocity. Okay, then question B, velocity is this, and time taken is 6 seconds. Find the displacement, and C is velocity is given, displacement given, and find the time taken. So let me just go ahead and demarcate my board in order to manage my space well, guys. ABC. Let me just do it like this. Okay, so ABC. So I'll just solve A here, B here, then C there. Okay, so let's get started with question A. Now this is displacement. Okay, don't forget that displacement is also what? It's a vector quantity, a scalar vector quantity, and time is a scalar quantity. Okay, so I want to find vector quantity, that is velocity. So and I have this already, so I don't have much trouble. Okay, so don't forget velocity is what? Velocity is given as displacement over time. Let me just use d, sorry about, let's use d for displacement and t for time. So I have displacement is given already 21. Okay, so that is 21 I. Okay, because it's vector quantity, so you have to put in your unit this direction. So I direction, that is x coordinate, something like that, to maybe toward the right or left, and this j is up or down, or north or south, east, west, something like that. So this is displacement, which is, so it should be in this form because it's directional. Okay, the magnitude and the direction, then divided by the time taken is 6. So you can take it 121 over 6 I, 21 over 6 I. Okay, then plus 54 over 6j. So this time, guys, I think I may need to get access to my calculator. Yeah, So what do I have here? 21. 21 divided by 6 equals to 7 over 2. In decimal, that is 3.5. So that is 3.5i. 3.5i, okay, plus 54 divided by 6. 54 divided by 6 equals to 9j. So that's 9j. Guys, that's cool. So let's go for B. This asks me to find the displacement. Displacement, this is also a vector quantity, so I can go ahead and just do change of your formula here. So D will be velocity times time. So displacement equals to Vt. Okay, Vt. Yeah. I was like, what is going on? Yeah, Vt. Yeah, just cross multiply Vt. So I have the time here 6, so I can just do 6 into 6 into I have the velocity here, so that is 5i minus 6j. So do I need calculator to complete this? Hello, why are you lazy? You don't even know how to multiply. Yeah, 6 times 5 is 30. I know this one, guys. Okay, so this is 30i and minus 36j. I hope I'm cool. Guys, I'm now good with multiplication. Okay, so that's cool, right? So 30i minus 36j. So C, I don't know, let me just start C here. I still have space here. I'll continue if this is not enough. So I'm to find the time taken. Don't forget that time is a scalar quantity. So in that case, now you should have a real value, and you don't need to have your I and J there. So yeah, from here also, if you cross multiply Vt equals to D, so then C will be D over V. So time taken will be displacement over velocity. Okay, so what is the displacement now? The displacement, we have the displacement is given to be this now. Okay, now if you look at this now, this is 4 minus 50 and 50. So if you use either, for example, if you have 50 over minus 4 is same thing as 50 over, okay, don't mind me. If you have minus 50 over minus 4 is the same thing as 50 over 4. So I don't need to waste much time either way. So you can use either of the components. So I have 50, okay, divided by 4. Or better still, if you want to do it other way, the same. If you want to do exponent, and that is minus 50 over minus 4. So you see that it's cool, pretty cool, right? Still give it this. So what is that? Let me go ahead with my calculator. 50 divided by 4 equals to 25 over 2 is 12.5. So this equals to 12.5. Okay, and that's second. Okay, 12. Oh, why am I like this? I'm sorry about that. It's 12.5. Then I can put my second now. So it's second. Oh, my second is not like 5. Okay, so that's sec. Okay, guys, method 2 for this, you can also do, or you can do this now, since time is a scalar quantity. So instead of displacement, you can just do distance, then instead of velocity over speed, something like distance over speed. So mean that you should go ahead and find the magnitude of the displacement, that is the modulus, and that would be square root of the component of x, so that is 50 square. Minus 50 square will give you the same thing as 50 square, okay? So plus, and the y component, that is 50 square. So that should give you the magnitude of the displacement, and which is equivalent to the distance, okay? Then divided by, then the magnitude of the velocity, and that is equivalent to the speed. So and that is minus 4 square, same thing as 4. So let me just write it as 4 square if you don't mind. So minus 4 square will give you the same thing as 4 square. This is the I component, and the j component is also 4 square, okay? So now we go with that. Now you have 50 square, that is 2500 plus 2500, that is 5000, okay? Then 16 square plus 16 square, that is square root of 32. So let me take my calculator and complete that now. So I have square root of, I'll just plug in there, okay? Square root of 5000, and that equals to 50 root 2. So that equals to 50 root 2. 50 root 2, then divided by square root of 32. Okay, square root of 32, and that is also 4 root 2. So if you do this, also we end up with what we have in there, 50 over 4, because this one cancel out, so you still come back to your answer there. Okay guys, so either way I believe is cool. I wouldn't know, you may like it like this, or better still go this, because this is actually scalar quantity, so you can just change this your displacement to distance and this, and I think I'm cool with this second method. Okay, I think it's better. I think I'm cool with this one. Okay, so the answer is 12.5 seconds. Okay, okay guys, here is the next question. A car travel from a point A with position vector 60i minus 40j and kilometer to point B with position vector minus 50i plus 18j kilometer, and the car travel with a constant velocity and take 5 hours to complete the journey. Find the velocity vector. I see, find the velocity vector. So trying to emphasize the fact that velocity is actually vector quantity, guys. Okay, so that's pretty cool, right? Cool. Okay, so yeah, let's get started now. The first thing here is that I can travel from a point A with the position vector, so that is position vector of A relative to yeah, O, because a position vector. So and that is your OA. I don't know, do I need to waste much time? Yeah. Okay, so OA, that is given already. Let me write it as a column vector, so that is 60i. Oh, my handwriting is pretty cool, right? Sorry about that. Minus 40j. Okay, so that's cool. Yeah, so to point B, so that is OB. Okay, sorry about that, I need to put my direction. Okay, so OB, that is position vector of B relative to O, and that is, let me write as a column vector 2, as a column vector, that is 50i, then 18j. Okay, I need to be careful with my operators and signs. Okay, yeah, so the car travel with a constant velocity take 5 now. So from A to B now, so let's just go ahead and A to B. So A to B now, that is position vector of B relative to A now, because this is actually position vector of A relative to O and B relative to O. So you for A to B now for the entire journey, so you have B relative to A now. So don't forget how to do the, I don't know, I'm almost completing the task without, let me just resolve it first. So that would be what? AO. So I think for the first, in the first 2-3 questions, I explained this better, so I will need not to waste my time explaining again. You already understand what I'm doing. Then OB. Okay, such that this cancel out. Okay, so what do we have in here? Then don't forget this is OA, but this is AO. Okay, so that will be minus. You understand this already, so that will be minus AO will be minus OA. So negative of this one, that is minus 60i, minus 60i, then a negative of this one, that is 40j. Okay, then plus OB. So OB, I'm going to leave it the way it is, so that is minus 50i, minus 50i, and 18j. Okay guys, next now just go ahead and resolve the I and j's component. So minus 50 minus 60, and that is minus 110. So minus 110i, and this will give me 50, no, 60. 4 plus 1, that is 58. Okay, so 58j, 58j. Okay, so I have AB now, so that's my AB. So that's position vector of B relative to A. Position vector of B relative to A. Okay, so now I have my this is, don't forget, this is position vector of B relative to A. So at time t, so velocity is giving us what? So velocity is what? Displacement. Okay, divided by time. So that you can rewrite this one as displacement times 1 over t. Inverse of time is the same thing, right? So let me just write my 1 over t, 1 over time. So the time given is 5 hours, so this kilometer per hour, so I don't need to do any conversion. So then the distance now, the displacement better to do my, I'm sorry about that. So this is displacement, So that is minus 110I. Okay, then now 58J. And since this is velocity, so you need to retain your direction, your I and J component. So now let me just go ahead and use my calculator now. 1110 divided by 5, or 1110 times 1 over 5, either way. So 110 divided by 5, that is 22. So if you don't mind, I can also write it as a column vector. So that is minus 2, minus 22I. Then go ahead and do 58 divided by 5, or better still 58 times inverse of 5. So 58 divided by 5 equals 2. So that is 11.6J. 11.6J. If you don't want to express it as a column vector, you can also write it as something like minus or equivalent. So minus 22I, the examiner will still give you as equal minus 22I plus 11.6J. You are still cool, guys. Hope that is cool. Okay, guys, let's go to the next question, guys. Let's go to the next question. Minus 22I plus 11.6J. Okay, guys, here is my YouTube channel. Immediately after this session, the video on position vector, vectors, geometry, and relative velocity will be available via my YouTube channel. There are quite good numbers of videos that will help you guys enhance your learning, additional mathematics, ICT, robotics, and coding videos. Most of the Add Maths, and ICT video here are actually exam style question, IGCSE, GCSE exam style question to be specific. So you can see something on transformation matrix and numbers, system solving polygon, creating artificial intelligence, scratch programming. You can develop your own game using block or scratch programming, simulating binomial density function using Excel, graph of trigonometry, that's tree graph, statistics and probability and statistics function, and data analysis, and many more. So if you find any of my video quite useful or interesting, guys, just go ahead and click like. You can also help subscribe to my channel, guys. Subscribe to my channel, guys. Okay, so that will really encourage me to do more. Okay, here is my YouTube channel, guys. There are quite good number of e-learning resources, wonderful e-learning resources, and all videos on my YouTube channel are also available via my test shop, guys. So if you find any of my e-learning resources useful and helpful, just go ahead and help review in order to see what I can do to help improve on my resources. Okay, guys, at this point now, let's call it a day. Love you guys. To have a great day ahead. Let's end with this note, guys. Let's end with this note.
Break the streets up.